So as I said, chapter 9 is all about conic sections or conics. There are four main types of conics that we'll cover over the next few sections. The first one we'll talk about is parabolas. These parabolas are the same type of parabolas we see when we graph quadratics. Now we just talk about them in a different context. So when we graph them, we're going to be including different critical points. So a parabola can also be defined as the set of points in a coordinate plane that are equidistant from a fixed point, your focus, and a fixed line called the directrix. So every point on your parabola is the same distance away from the focus and the directrix. The vertex of the parabola happens to be halfway between your focus and directrix, and your axis of symmetry is the line that runs through them. It's also perpendicular to your directrix. So the axis of symmetry and the vertex are both terms we've talked about before, but our focus and directrix are new terms for us that we use when we graph parabolas in the context of conic sections. So parabolas can have a vertical axis of symmetry or a horizontal axis of symmetry, meaning they open left or right. So we'll first talk about the ones that have a vertical axis of symmetry. So we've seen these equations before, but our quote-unquote standard form of our equation is going to look a little different. This time it's x minus h squared equals 4c times y minus k. Notice we don't have to solve for y anymore to get it into what we are going to call standard form. So our vertex is still at hk, that's nice. Our focus is c units away from hk, either moving up or down, depending on whether it opens up or down. And your directrix is just in the opposite direction. Remember, it's a line, so it's an equation of y equals something. Now, your focal diameter is going to be the distance from one edge of the parabola to the other that runs through your focus. So your focal diameter would look kind of like that. And the distance from one edge to the other is going to be 4 times your c value, which remember we used to find our focus. And it's always going to be positive though, because we're talking about distance. Also, before we start, one thing to note, your parabola always opens around your focus. So it kind of encompasses it. And notice c is the distance between the vertex and the directrix and the vertex and the focus. So that helps us find our focus and directrix. So first example, we want to find the equation of the parabola with the vertex 0, 0 and focus 0, 2. We need to sketch the graph and include basically everything we need. So when we graph parabolas in the context of conic sections, I always just make a list right away. So we are going to need our equation, our vertex, our focus, our focal diameter, and our directrix. Some of the pieces of information we'll have each time, sometimes we'll have to find things. So we know our vertex is 0, 0, and we know that our focus is 0, 2. So before even moving on, I would start to think about the graph. So 0, 0 is our vertex, our focus is 0, 2, so we're going to move up 2, that's our focus. So right away we know that our parabola is going to open up because it has to open around the focus. So remember that your focus is the same distance away from your directrix. So that means if our focus is 2 units up, we can move 2 units down, and that will help us find our directrix. Now the directrix is not technically part of your parabola, so if you want to use a dashed line, you certainly may, but you don't have to. So we have our directrix. Let's put that in our column of information. It's the equation y equals -2. So our focal diameter is going to be found by using information from our focus. So we know that our focus is 2 units away from our vertex. So that must mean that our c value from up above is going to be 2. Our focal diameter always has the distance, the absolute value of 4c. So absolute value of 4c is going to be 8. So in order to graph that, remember that it's symmetrical. So we don't want to move 8 units to the left, 8 units to the right, because that would give us 16. We're going to move 4 units to the left, plot a point, and 4 units to the right, and plot that point. So that's all we need to graph. We just need to include our vertex, our focus, our directrix, and the endpoints of our focal diameter. Lastly, we'll find our equation. So the nice thing is that our vertex is 0, 0. So h and k are both 0. So it's going to be x squared equals 4c. Well, we said c was 2, which we got from our focus. So then it's going to be 8 times y. Now notice that your focal diameter is always going to be the same number you see here, except it'll always be positive. Now in this case, we knew it was positive because our parabola is opening up, so that told us that we're going to have a positive value of 4c in our equation. So our next example, we need to find the focus and directrix of this parabola and sketch the graph. So again, start by writing your list of values you need. So we're going to need the equation, the vertex, the focus, the focal diameter, and the directrix. This time we have the equation, but remember when we talked about our quote-unquote standard form, whatever was squared was always on the side of the equal sign by itself. So we want to get x squared all by itself, meaning we're going to divide both sides by -1 to get rid of that coefficient on x squared. So really, I'm going to call my equation x squared equals -y. Now, our vertex, we have no h or k. Well, that's nice. Our vertex must be 0, 0 then. Our focus we can find by remembering that whatever's your coefficient of y is going to be, oh, that's actually 4c. So in this case, 4c is -1. If we solve for c, we divide by 4. Our c is -1/4. Now I always plot it first and then find my ordered pair because that's going to be a little bit easier than memorizing, oh, you take your c and you add k, whatever. No, I plot it first. Now our c is a -1/4. Since our c is negative, that tells us we're going to be opening down. Since x is squared, that tells us we're opening up or down. C is negative, that means we're opening down. So that means I need to move 1/4 unit away, but in the negative y direction. I'm going to go ahead and let every 4 tick marks be 1. So then each tick mark stands for 1/4. So when I move 1/4 unit down, I'm going to move 1 tick mark down, just for the sake of being economical in our space. So we have that C value, 1/4 unit down. Now we can plot that point and label that point. So our focus is going to be 0, -1/4. Our focal diameter, remember, is always the absolute value of 4c, which we found from our equation. Oh, it's just going to be your coefficient of y, but magically positive. Or you can plug in your c value, you get there either way. Your focal diameter is going to be 1, which means you're going to move a half to the left and a half to the right. Lastly, we just need our directrix. If our focus was a 1/4 unit down, our directrix is going to be a 1/4 unit up. So the equation of that line is going to be y equals positive 1/4. We have everything we need for our graph, so now we can move on. Now, we won't always have parabolas that open up or down. That's what we're used to, but if we don't limit ourselves to talking about a function, meaning it has to pass the vertical line test, then we can say, oh, we can graph parabolas with a horizontal axis of symmetry, meaning it's going to open left or right. Same idea as far as opening up or down. If it's going to open right, that means your C is going to be positive. If it opens left, your C is negative. Notice our equation is really, really similar, but this time your y is being squared and your x is on the other side of the equation not by itself, but with the 4c. Same pieces of information over here. Your vertex is still hk, your focus is still c units away, but notice we're moving it from h, which means our focus is going to be to the left or right of our vertex. Our directrix is going to be on the opposite side. Notice it's the equation x equals something. Well, that makes sense. It has to be perpendicular to our horizontal axis, which means that it's going to be a vertical. And if you think back to when we had vertical lines with an undefined slope, oh, is of the form x equals. Your focal diameter is still the absolute value of 4c. That didn't change at all. So now we want to find the equation of the parabola with that focus and that directrix. Sketch the graph, including the focus and the directrix. I start by making my list of things I need. So I'm going to need my equation, my vertex, my focus, my focal diameter, and my directrix. So they gave me my focus of 2.752 and the directrix x equals 3.25. I'm going to start by plotting those points before I move on, or point and line. Again, I'm going to let every 4 tick marks be 1 for the sake of using all of my space. So when I plot my focus, ooh, maybe that was a bad idea. Okay, we're going to let every other tick mark be 1. There we go. So now we're going to move 2.75 units to the right and 2 up. So 2.75 up 2 is going to be right there. And then our directrix is over at 3.25. So it's going to be right here. There we are. So that's going to help us find our vertex. Remember that your directrix and your focus are both equidistant from your vertex. Well, where's the average between 2.75 and 3.25? Oh, it's going to be right at 3. So once you plot it, I think it's easier to find your ordered pair and your vertex after it. So that point looks like it's going to be the ordered pair 3, 2. Now we need our focal diameter. So our focal diameter, remember, is going to be found by taking the absolute value of 4c. Well, we don't know our c value, but if we think about how far away our vertex is from our focus and how far our vertex is from our directrix, they're both 0.25 units away. So that must mean that our c is 0.25, and I'm going to come back to that in a second. So our focal diameter is going to be 4 times that. So it'll be 1, which means I'm going to need to move a half unit up, which will be there. Oops, from the focus, sorry. Half a unit up, half a unit down. And that's 1 tick mark. Okay, lots of points. I want to move half a point up, half point down. There we go. Good enough. There we are. Now, notice that our parabola is opening left. So can our c be positive? Our c value actually needs to be a negative 0.25. Now, we didn't care last time because we took the absolute value anyway, but we'll keep that in mind as we write our equation. So our parabola opens to the left, so that means that x is going to be squared, but we need to include our vertex, so it'll be x minus 3. Nope, I lied. That's a lie. Just kidding. It's opening to the left. Y needs to be squared. Sorry. So our y needs to be squared, and we're going to include the k value for the first part of our equation. So I'm going to have y minus 2 squared equals 4c, which is going to be the focal diameter, but remember that your c is negative. So it's going to be a negative x minus 3. Running out of space there. Okay, so since it opened left, that meant that y was squared, which means that we need to include the k value with that. Oh, yeah, k value with that, and then our h value with our x. And then don't forget that squared isn't there anymore. So only one thing is squared, and in this case it's the y because we're opening to the left. Okay, got our way through that one. Last one we'll graph by hand is example 4. So find the focus, focal diameter, directrix, yada yada. Start with the same list. Equation, vertex, focus, focal diameter, and directrix. This time they gave us the equation, but again, let's put it in the form that will be most useful to us. So that means that we need to get whatever's squared by itself, so in this case y squared. So we're going to subtract 6x to the other side. So our equation is really y squared equals negative 6x. Our vertex, since nothing is being added to y or x, our hk is 0, 0. Always nice when that happens. Our focus, we will get by using our coefficient of x. So our focus is going to be found by finding our c first. Remember that in our equation, we always see a 4c in front of our x if it has a horizontal axis of symmetry. So then we're going to say, oh, 4c equals -6. We solve for c, oh my gosh, divide by 4. So c is a -3/2 or a -1.5. So we need to think about what our graph is going to look like, and then that'll help us kind of fill in the rest. So y is squared, which means we're going to be opening left or right. C is negative, which means we're going to be opening to the left. So that means I need to move 1.5 units to the left to plot my focus. 1.5 units to the left is going to be my focus, which means 1.5 units to the right is going to be my directrix. Then we name that ordered pair in that equation of that line. So our focus, since we moved 1.5 units to the left, -1.50, focal diameter, oh no, not that, directrix is the equation x equals +3/2 or +1.5. Our focal diameter, remember, is whatever we see here but positive. Or you can think about it as the absolute value of 4c, which we plug in the c, we find that it's going to be 6 either way. So that means we need to move up 3 and down 3 since it's symmetrical. Okay, try to go through your points. And there we are. Lastly, we're going to talk about how we can graph this using our graphing calculator. Now, remember that our graphing calculator is a little limited because the only thing we are able to graph is something of the form y equals. So for both of these, we're going to have to rearrange things so we can get y by itself. So in example A, it's not terrible. All we have to do is divide by 16. So we're going to plot y equals x squared over 16. You can think about it as 1/16 x squared. I don't care. For the sake of pressing fewer buttons, I'm going to call it x squared over 16. So x squared over 16. We'll go to a standard window and see what that does. Oh, it's not too bad of a picture. So let's just make sure that this is in fact a good picture. If we think about our c value and our focal diameter, well, in the equation they gave us, x squared was by itself, that's good. So then the 16, our coefficient of y, is going to be 4c. Oh, okay, c is 4. So then that means that our focus is 4 units up. We want to make sure that we have our focus and our focal diameter in view of our window, and we do. I'm not so concerned that you graph it, especially as it's asking for just a quick sketch, but just make sure that you're getting a relatively accurate view. So our graph looks like that, and we include our windows, which was just standard, -10 to 10 in every direction. Okay, example B, we want to graph that guy, but y is not by itself, so I need to solve for y. When I do, we need to remember that when we take the square root, it's not just going to be the square root of 2x, because if we think about that graph, that's just going to be the top part of a curve. I need both the positive and negative square root of 2x, which makes sense. You need the top part of the parabola and the bottom part. So we will graph the positive square root of 2x and the negative square root of 2x. You don't need to close your parentheses, I just do because that's me. Wait for our graph to show up. Again, we start to think about where our focus is, what our focal diameter would be. This in front of our x is 4c, which means our c is 1/2. So our focus is only a 1/2 unit away from that origin, that vertex, which also happens to be the origin. So I have a great view of it. We're good to go. So we'll draw in that sketch, pretty skinny parabola, throw in our windows, and call it good.